Hello everyone and welcome to Deercraft. Today we are starting a new series called Project Skyblock. Of course, I am talking about hypixel Skyblock. This is essentially a method to use OpenCV and C++ to play certain aspects of the game. First things first, a huge disclaimer. This bot demands constant human attention. There are many unresolvable circumstances that arise from game mechanics which are too complex for a bot to solve. For example, when farming in hypixel garden, one cannot expect an AI bot as of now to catch pests on its own. Hence, I am not responsible if you fail the macro check like Tesla drivers who watch anime while using FSD. With that being said, let's get down to business. This bot will be written in C++ and OpenCV. Whether your OpenCV supports CUDA or not does not matter, because most of this runs on CPU only. Now you might be asking, why not Python? Why not MCscreenshot? Because firstly, Python is slow as hell when compared to C++, and it doesn't have a readily available executable to run repeatedly. And secondly, I could use MCscreenshot, but where's the fun in that? So let us start first with the most basic class. This is the PauseController. We need this because our robot is multi-threaded and we need to communicate between threads for it to function properly. Also, we need this to handle things such as emergency stops and pauses that occur during play. For example, when farming, pests spawn. We can either farm one block and take care of 4 pests, or take care of the pests immediately after they spawn. If you don't know what a PauseController is, then you need to go back to school. If you don't know what a PauseController is, then just find an emergency stop button. That button immediately stops the entire machine when it is pressed. It is needed because we cannot just pull the plug, and the machine needs to come to a stop safely instead of just free coasting. This might sound outlandish to Python programmers because they don't need to handle all the memory recycling and release when a program stops. They just do system.exit. However, C++ is different, and that is required. Hence, we need an emergency stop. Now let's start going through this class step by step. First are the includes. This pragma once ensures that everything is included only once during compilation. The mutex class is used to ensure that only one thread accesses the data at a time. Again, if you don't know what a mutex is, then you need to go back to school. Think of a mutex as a public restroom. Only one person can be in it at a time. The others, no matter how urgent they are, have to wait outside. Of course, this can lead to some unforeseen circumstances like leakages. However, that is not the subject of this video. Alright, now let's look at the class variables. Firstly, the private ones. These are Boolean variables that store pause states of various degrees. The paused variable is just a soft pause, and it waits for the thread to reach a certain point. For example, in farming, this is when a block is finished farming. The main pause is for a faster subthread, like the image recognition thread, to stop when the main thread, the slower one, is stopped. The allow is a hard pause, which immediately pauses the main thread. The stop requested variable is an emergency stop. When this is true, the program immediately stops and all threads end and the memory is cleared out. The complete is for the main thread, such as farming, to signal everyone that the task is done and for everyone to shut down. The stop mutex is used to ensure that only one thread changes these variables at a time. The print mutex is a mutex for printing. This is used when debugging to prevent the race condition. This is used because it confuses the debugger whether a thread went first or second. If we keep going down, we come to the public sector of the class. First is this mutex, which is a general purpose for the threads to use for their own purposes. Next is the condition variable, mainly to notify all threads if one of the above variables are changed. Next are the functions. The print line is just a wrapper around the cout, which requires acquiring the print mutex to use. This ensures a print order when debugging. Next is the toggle pause. This is called when the keyboard listener thread detects a key press that changes the pause state. It beeps high when it is resumed, and beeps low when it is pausing. Then it toggles pause. When clearing the pause, it also clears main pause. Then it's the set complete, and since complete will only be set once at the end of the program, there is no clear complete. Then is the is complete, which just returns the state of complete variable. Then the set pause and clear pause. As the toggle pause, these set and clear the pause state, because sometimes we need to just simply set a pause. For example, during farming, that is not a Jacob's contest. We can farm a block, kill 4 pests, and come back again. However, we want this stop to be automatic. Hence, we use a set pause function. Next is the wait if pause function. This just simply blocks the thread if the pause variable is true, and waits until it is cleared. Same with wait if main pause. This is for the faster subthread to pause indefinitely. Then is the wait for function. This delays for a specific amount of seconds before it clears. During this time, if there is an emergency stop, it returns immediately, and the function that calls it executes the shutdown routine. Next is the request stop, which is pressing the e-stop button. Is paused simply returns paused. Is stopped simply returns stop requested. Is main pause simply returns that variable. And set and clear main pause. Self-explanatory. The halt is for a hard pause, which uses the function allow or stop requested. Then is the allowing and request. And allowing simply returns the variable, and these two just reset and set the variable. So now I will also give an overview of the MCscreenshot class. Up here, we have all the includes. A few notable ones are the mutex, and the map, and the algorithm. This class handles all of the taking screenshots and recognizing the characters. Also, it handles changing those strings into actual data. Here are the private variables and constants for the class. Firstly are the rectangles that store where each piece of information can be found on the screen. I am using a resolution of 1920 x 1200 in big window mode. This means that you full size the window, but do not press F11 to make it full screen. The first one, info screen, stores the rectangle that we were to take one screenshot and acquire all the information. And these 4 recs store the area of their respective information. This map is only there for ease of access, so that we can reference each rect with a name, a string. This map here stores the OCR ending condition for each section. We can see that for yaw and pitch, we end with VE, and for position, we end with Z, etc. This constant is for storing the number of pixels of the overhead window bar. It is right here, from the top of the screen to the actual content of the window. This Ch.1 stores how many characters are there to match, and it is used to initialize this constant array of strings, which contains all the characters from 0 to 9, A to Z, and then finally some special symbols like comma, dash, parentheses, and equal sign, which is actually a slash. So the reason this is actually a slash is because in Windows, you can't name a file containing slashes. And also, we can see there are X2 and Z2 here. This is because these two characters are both uppercase in the coordinate names and lowercase in the block names. These two constant integers store the width and height of each character. If a character's contour and bounding rect are smaller, they will be resized to fit this, as we will see later. This math array is for storing the char matching templates that are loaded during initialization. These constant floats are for the matching thresholds. The match file is very low because it is for the square difference norm method. This match correlation value is very high because this is for the correlation norm method, and it is the larger the better. This function captures the screenshot. It takes two parameters, a window object and an area that needs to take the screenshot of. First, it declares two maps, and then all of this is from ChatGPT. I have not moved it one single bit, and yet it works perfectly. So down here, we first convert the color from BGRA to BGR. BGRA is a 4-channel color scheme that the screen display uses, and BGR is just an intermediary, stands for blue, green, red. And then we convert the BGR into HSV. This is required because in HSV, it is easier to isolate the white characters from background noise. Next, we define an upper and a lower limit for white color, and then we apply a filter and input the results into mask. Then we return mask. Next is this function, image to chars. It takes a single image and extracts the characters within. First, it finds all of the contours, which represent the characters. Next, it extracts the bounding boxes of the contours here. Note that contours with areas smaller than 10 or larger than 350 are ignored. For areas that are smaller than 10, this can include dots, such as the dot on I, J, and semicolons and colons. And it pushes all of them into a vector. Next, the program sorts the vector from top to bottom and left to right. This is to extract the original order of the characters. Finally, it crops all of the characters and pushes each individual into a vector. Here, it resizes each image into the given constant size. This is to ensure that all of the characters, including slashes, commas, and parentheses, have the same size so that OpenCV does not throw an error during template matching. Finally, it returns the results. The next function, matchChar, is the core of recognition. It takes a single character and returns the string that matches it. First, it scans through each template and conducts a match template using the squared difference method, norm. Then, if the minimum value is less than the matching threshold, then it returns the string. If there is no match, then it conducts a secondary matching loop using the correlation norm method. Same as above, if the max value is greater than the threshold, then it returns the string. If there is no match, then it saves the failed character as an image and returns an empty string. The second loop is needed because once I found that a character K is shifted to the left, but the one saved as file is actually in the center, I did not bother to find the bugs. Hence, I used this method to cover the error. The next function, matchToString, just combines the above two functions. It converts a single image and returns a string, and takes in an end string as the ending conditions for the string analysis. So firstly, it converts the single image into multiple characters inside a vector using the image2chars function. Next, for each character inside the vector, it attempts to match the char using the matchChar function. If an empty string is returned, it means there is an error. So it outputs an error message and concatenates the vector into a single image and shows it, and returns the empty string. For each loop, if it is correctly matched, then it adds the character onto the front of the string. And if the ending condition is met, it breaks. So this saves a lot of trouble since it doesn't recognize any characters that are irrelevant to the data. Finally, it crops the string of the end string and returns the results. Now we come to the public section of the class. These four functions all convert the string obtained from matchToString into usable data. For example, the getYourPitch function converts the string into a .2f object that stores the yaw and pitch. The getPlayerPause function converts the string into a .3f object. The getBlockPause converts the string into a .3d object. The difference between .3d and .3f is that f stands for float and d stands for integer. Finally, the getBlockName function just converts the string into a block name by, as we can see here, removing the dashes and the underscores. This is the initialization function for the class. This has to be run by the main program since it includes an error which is file not found. For each character, it generates an address and looks for the file. If the file is not found, it outputs the error message and returns false. Then it saves the math into the class variable above. If there are no problems found, it returns true. The saveChar function is used to save the character images. This only needs to be used when setting up the system's files. So it first waits for 3 seconds to allow the user to switch from this terminal into Minecraft. Then it takes a screenshot of everything and breaks it into individual characters. Immediately after, it saves those characters using an arbitrary file name. Then the user has to manually change those names to match the ones it given in the class constant. And here is the last and biggest function of the class. It can be considered the main, since most programs will call this. It returns a map of string to string and takes in a vector of strings, which is the area of interest. Firstly, it checks if the vector is empty. Next, it finds the bounding rectangle. In most cases, it might require multiple ROIs. Hence, it finds the biggest rectangle that contains all of the areas that are needed. Then it takes just one screenshot. Next, it extracts the individual ROIs. So for each ROI area, it first reads the bounding box from the class constant, and then it calculates the relative rectangle of the area. Finally, it crops the area into the vector max. Finally, it conducts the image to string conversion by calling the function map2string, and it returns the map to the function calling it. So that is all for this introduction. If you would like to see more, please subscribe to get notified. Thank you for watching.